Hey guys, this is Miss Farnell. I am going over another AGS 1 lesson with you. This will be probability. Before I get started with the lesson though, a couple things. Just make sure that you do have a writing utensil that you can follow along, take notes with. Make sure that you have a note sheet. It should be like the one that I have here. If you do not have that, you can go ahead and ask your teacher for one. And then if you would like a calculator, you can get a calculator for this video. You probably won't need one, but just in case, you can grab a calculator. Okay, moving on to the lesson. So, like I said, we're going to be talking about probability. We are going to be covering a lot of different things in this video, so please make sure, if you need a moment to just kind of take it in, please feel free to pause the video at any point, write down what you need to get written down, anything like that. I'm just going to kind of go. Okay. So in this case, finding probability. This is something that you've probably done before in your previous classes and things like that. Finding probability is just finding how likely is something actually going to happen. What's the likelihood of this happening or that happening? So the way that we notate it is with a P. So this P literally stands for probability. And then this A right here is going to be an event. We call it an event, but really just like an event in probability standpoint or in math really just means like something's happening. What the probability of this specific thing happening? What is that probability? So in this case, the way that this works is there's two different numbers that you have to figure out. That's it. So to find the probability of something, you're going to take the number of outcomes that fit event A. So the number of different ways that you can get event A to happen. And that might not make any sense, and I feel like it'll make more sense once we get to kind of more of the examples later. But how many of them fit this description divided by the total number of outcomes? Like, how many different ways can this one thing happen? So if that doesn't make sense, I hopefully will explain it when we get these other examples going over here. So this first question says, find the probability of rolling an even number on a die. If you don't know, a die is just a dice. It's just the singular version of it. I'm not telling you to die. That's not a typo. It's dice. It's just the singular. Anyway, so find the probability of rolling an even number on a die. In this case, so the way that you're going to think about it is, how many different things do I get when I roll a die? When I'm rolling a die, just a standard die, in this case, there's 6 possible things that you could get. You could roll it and get a 1. You get a 2, a 3, a 4, a 5, or a 6. That's what you get when you roll dice. I want something from 1 through 6. So this case, these are all of the possible outcomes. In this case, what I would do to find the probability, on the bottom where it says the number of total outcomes, however many different things you can get when you do the action that the question talks about. So in this case, when rolling a die, the number of things that we can get when we do that, that's the total number of outcomes. So in this case, that's 6. There are 6 different things that you could possibly get when you roll a die. A 1, a 2, a 3, a 4, a 5, or a 6. From there, what we're going to do is we're going to figure out how many of them fit the specific description of the question, though. In this case, it's asking about rolling an even number. So we're going to look at all of our possible outcomes, and we're going to look at how many of these fit the description of being an even number. In this case, I would say that's the 2, the 4, and the 6. So that's 3 numbers. 3 out of the 6 numbers are going to be even numbers. So in this case, that's the answer. The probability of rolling an even number is going to be equal to 3 out of 6. So this P, just as a reminder, that means the probability. I can spell, I promise. Probability. And then in this case, the even number thing, that's our event. That's the thing that we're trying to find the probability of, that we get an even number. It's a 3 out of 6 chance. In this case, you might want to simplify your fraction. I'm not against it if you don't. If you leave it like this, that's totally fine. But in math, when we have a fraction and we can simplify it, normally we want to do that. So I have a 3 and I have a 6. I would figure out the biggest number I can divide both of those by. In this case, that's going to be a 3. I can divide both of them by 3. 3 divided by 3 gets you a 1. And then 6 divided by 3 gets you a 2. So it's a 1 out of 2 chance. or a 3 out of 6 chance that you're going to get an even number. Both of those answers work. I would accept either one. Okay, so if you want to try this next question on your own, go ahead and pause this video and then try to practice that yourself. Okay, and then I am going to do it now. So it says find the probability of flipping a coin and getting heads. So the very first thing that I would think about is what are all of the possible things I could get when I roll a die, when I flip a coin. In this case, the two possible things that we could possibly get are heads, and then we can get tails. Those are kind of like the two only options, heads or tails. So in this case, how many different outcomes is that? That's 2. So the total outcomes is 2. That's the number that's going to go on the bottom. So now from here, on the top, I'm going to put the number of different of these outcomes, how many of them actually fit the description of being heads. Well, it's only one, the one that's heads in that case. So it's pretty simple. It's just the one. So in this case, it's 1 out of the 2. Out of the 2 possible outcomes, only one of them is heads. So it's a 1 out of 2 chance in that case, or 1/2. All right, so that would be the answer for that one. So moving on to something kind of similar, but a little bit different, is a lot of times, and you're going to see this a lot with the future questions, is we're going to be finding the probability of 2 different things happening at the same exact time. So in this case, we're going to talk about like you flipping a coin and rolling a die at the same exact time, or just the probability of me going for a walk and somebody else staying inside or something like that. What's the probability of 2 different things happening at the same exact time? So in this case, this is just like a generic formula. So they're going to call it event A and event B. But just know like A could be replaced with you flipping a coin and B would be like you rolling a die. Like those are the 2 possible things happening. So the probability of both of those things happening at the same exact time, the way that you find that is actually by taking the probabilities of them individually. So probability of you flipping or getting an even number on something, so like we did up here, and the probability of you flipping and getting a heads, and just multiplying those together. Multiply. So in this case, what you do to find the probability of 2 things happening at the same time, just take the 2 individual probabilities and multiply them together, and that's going to be the answer. So I'm going to show you guys what types of questions you might see on this quiz that kind of go with that. So the question says the probability that Max wears blue is 0.4. So you'll notice this is a decimal. It's not necessarily a fraction. Sometimes we kind of go back and forth between fractions. We use decimals, we use percentages. They all work, they all function the same way. But in this case, it is going to give it to us as a decimal. So it says the probability that Max wears blue is 0.4, and the probability Aspen wears blue is 0.65. So in this case, one other way that you can think about it, and for some people this makes a lot more sense, is rather than thinking about these as decimals, is thinking about them as percentages. So like changing that 0.4 into something percent. And how you do that is by taking a decimal and just moving it 2 spots over to the right. So I'm going to write this down here. 0.4, taking the decimal and moving it to the right 2 spots. And then where you have a blank space, you'd put a 0 in there. So that would actually be 40%. So really when it says 0.4, that means that he has a 40% chance of wearing blue. And then in this case with Aspen where it says 0.65, move the decimal over 2 spots, and really that's 65%. We use the decimals for a math, but if you want to think about it as percentages to kind of help that make more sense to you, that works either way. So in this case, it says find the probability of them both wearing blue. So in this case, the probability of the things happening at the same time, that's really the probability of Max wearing blue and Aspen wearing blue. That's what we're finding the probability of, that Max is wearing blue and Aspen is wearing blue. So according to this formula, what I could do is I could just take the probability of Max wearing blue, and then just multiply that with the probability of Aspen wearing blue. Just take those two things and multiply them together, and then that's going to be the answer. So when you guys do these math steps, this is where you're going to want to use the decimals rather than the percentages. The percentages is just there to kind of help you like process like what that actually means. The decimals are for the actual math part. In this case, this 0.4 and this 0.65 is what I'm going to use here. So we know that the probability of Max wearing blue is 0.4. The question tells you. So I'm just going to write that underneath, 0.4. And then I'm going to be multiplying that with the probability of Aspen wearing blue, which we already know from the question is at 0.65. From there, all you have to do is just multiply those two things together, and then that's going to be the answer. 0.4 multiplied with 0.65. In that case, you get 0.26. And then that could be the answer. Okay, so that's that. If you want to try this next one on your own, go ahead and pause it. If not, I'm just going to jump straight into it. So this question says, find the probability of Aspen wearing blue and Max not wearing blue. So this question's a little bit different because in this case, we have Aspen is going to be wearing blue, which we know the percentage of. We know that that's the 0.65. We know that that's the probability of her wearing blue. But we weren't told the probability of Max not wearing blue. We don't know that. It wasn't given to us in the question. I will say, though, it's actually very easy to figure it out ourselves. So this is when I kind of like to use the percentage kind of thought process rather than the decimal. So it says that like he has a 40% chance of wearing blue. 40% of the time he's not or he is wearing blue. In this case, so the probability of Max not wearing blue is going to be the opposite of that. 40%. So that means 100% of the time he's either wearing blue or he's not wearing blue. If 40% of the time he's wearing blue, that means it's 60% of the time he's not wearing blue. Because that's what makes it up to 100%. 60% and 40% make 100% of the time. So if he's wearing blue 40% of the time, 60% of the time he's not. Which in this case is actually just the decimal, 0.6. How I did that is I just took the invisible decimal that's at the end of 60 and I moved it back 2 spots. And I put it in front of the 6. So you'll see it's in front of the 6 there. So now from here, if I'm finding the probability of where Aspen is wearing blue and Max is not wearing blue, I now know this probability. So I can just multiply Aspen wearing blue with Max not wearing blue. Multiply those two probabilities together to get my answer. So the probability of Aspen wearing blue multiplied with the probability of Max not wearing blue. In this case, Aspen wearing blue, we already said that before, that was at 0.65. And then I'm just going to multiply that with Max not wearing blue, which is 0.6. So from here, you can just plug that into your calculator. So 0.65 times 0.6, hit the enter button, and you're going to get 0.39. And then that's going to be your answer from there. Okay, so that's the end of part 1. So that's just basic probabilities. So now we're going to move on to something called a two-dimensional grid. So two-dimensional grids, what are they? So a two-dimensional grid is used as a visual representation to show all of the possible, you're going to write outcomes here, of two different events. Let's just say two, sorry, of two different events. So just kind of like what we were talking about earlier with these things where we have two different things happening, we use a two-dimensional grid to show those two different things. So I'm going to show you guys how to make a two-dimensional grid with that. So it says make a 2D grid to show the outcomes of flipping a coin and rolling a die. So I'm going to show you guys what this two-dimensional grid, a grid has these arrows going up, an arrow going to the side. So in this case, the very first thing you need to do is identify what are the two different things that are happening in the question. So go back to the question. It says make a 2D grid to show the outcomes of flipping a coin and rolling a die. In this case, I'm going to underline the two different things that are happening. We're flipping a coin, we're rolling a die. Those are the two things. From here, I'm going to put those things on either side. So you notice we have an arrow pointing up, an arrow pointing to the side. Those are our axes in this case. I'm going to label each one of them with one of these things. So I'm going to label this one with the coin, and then this one with the die. So we have the coin, we have the die. So those are two separate things that are happening. Those are the individual events. From here, what I'm going to do along each of these arrows is I'm going to label all of the possible outcomes of each thing. And that's what it has written here. So put the outcomes of each event along the sides of the grid. So looking at, we'll just cover this up for just a second. Looking at the coin. When you flip a coin, what are the two possible outcomes when you flip a coin? Well, that's going to be heads and tails. Sweet. Awesome. That's it. Heads and tails. I just do H and T because it's easier to write. Down here at the bottom for a die, when we roll the die, we already talked about that earlier. That's the 1, 2, 3, 4, 5, and 6. So I know I could possibly get a 1, I could get a 2, I could get a 3, a 4, a 5, and a 6. So honestly, that's kind of like the meat and potatoes of it. Like that is like the biggest part is just labeling these sides. So from here, the last little step that you're going to do is you're going to fill in this two-dimensional grid with some dots. So the dots are going to be very important. You have to have the correct number of dots on here. They should line up with something on the bottom and something on the left. So 1 and T, they line up together, and then you're going to put a dot there. The 1 and the H, they should line up together, and you're going to put a dot there. From here, I'm not going to go any higher with my dots in that like column, just because I don't go up any higher with the things along this side. I can't go up any higher because there's nothing here. So I'm going to move on to the next spot. So the 2 and the T, the 2 and the H are going to have dots there. Then we're going to have 3T and 3H. And I'm just going to keep going. So I am going to stop after 6 over to the side. Why am I stopping here? There's nothing left past beyond the 6. There's nowhere else to go beyond that. So I'm just going to stop right there. So from here, I have all of those individual dots. So what these dots actually represent, and I have it written right here, each dot represents a possible outcome of both events. So in this case, like let's take this dot right here. This dot lines up with the 6 on the die and the T on the coin. So this is the person who is flipping a coin and then proceeding to roll a die after that. And what they got is they got tails and they got a 6. Like that's what that one outcome represents. Whereas like this one right here, this one represents me flipping a coin getting heads. And then it lines up with the 4 for the die, so it's heads and a 4. So that's what that means. That's what that represents. So each of these dots is a potential outcome. So that's going to be really helpful, and I'm going to show you how that's helpful with this example down here. So this question down here says make a 2D dimensional grid to show the outcomes of spinning a spinner. That should say A. Spinning a spinner with the spaces GRIDS twice. So this one's a little bit confusing because when you look at it, what I said up here is the very first thing you're going to look for are what are the two things that are happening. With this one, it only seems like there's one thing that's happening. You're spinning a spinner. But the two different things that are happening is the fact that you're spinning it twice. When you spin the spinner twice, you're going to get two different outcomes. So when I label these along the sides, I'm going to put spin 1 and I'm going to put spin 2. So what are the possible outcomes of me when I spin the spinner for the first time? Well, I could get a G, I could get an R, I could get an I could get a D, or I can get an S. So those are all of the possible things that I might get the first time I spin the spinner. Okay, cool. Then I'm going to spin the spinner for the second time. When I spin the spinner the second time, the outcomes don't change. It's all the same stuff on the spinner. So I could get a G, I could get an R, an I, a D, or an S. So that's what ends up going along each of the sides. So now that from here, the only thing that I have left to do is just filling in those dots. So I'm going to go 5 across this way because there's 5 letters. And then I'm going to end up going 5 up because there's 5 letters going upwards this way. So up, up. And then I'm just going to fill in all the dots from there. All the way up to the top. So again, what I have here now is I have this grid where each of these dots represents a possible outcome that I could get when I spin the spinner. So the first time I spin it, I could get an I. So that would be any of these possible outcomes here in the middle. Then the second time I spin it, let's say I get a D. So that would be this dot right here. I get an I first, then I get a D second. That's what this dot right here represents. So that's what that is. Over here on the right, it says use the 2D grid to find the probability of getting at least one R when spinning the spinner twice. So I'm going to show you guys what that looks like. So the probability, the way you find a probability, does not change in this case. It's still going to be total number of outcomes on the bottom. Total number of outcomes on the bottom. Sorry. I'm doing a really bad job of spelling right now. On the top, you're going to put the number of outcomes with an R. Because it says the probability of getting at least one R when you spin the spinner. So out of the 2 times that you spin it, you get an R at least one of those times. So I'm going to figure out how many of these outcomes have an R in it. And I'm going to divide that by the total number of outcomes. So I always like to find the bottom number first, the total number of outcomes. When you have a 2-dimensional grid, it's super easy. It's just however many dots there are. That's just the number of dots. So in this case, I'm just going to count up all the dots. I'm going to tell you right now, it's 25. There are 25 dots there. So there's 25 different outcomes. Each one of these dots is a different outcome. From there, on the top where it says number of outcomes with an R, I'm going to figure out which of these outcomes have an R. So like, for example, this one right here, this represents you getting a G first and then a G second. So in no way are you getting an R for this one. So I'm not going to include that one. But this one right here, this one represents me getting a G the first time, but an R the second time. So I did get an R there. So I'm going to use that specific outcome. So just to kind of speed this up a little bit, everything in this column right here, because it lines up with this R, is going to have an R in it. Like that. All of those have an R in it because they're in like the R column, as well as all of the ones in this like row right here. They also have an R, all have an R in it because they line up with this specific R. So I'm going to circle all of those. In this case, all of these ones that I just circled, that's the number of outcomes that have an R in it. So I'm just going to count up how many dots I just circled, and that's what I'm going to put up on the top. So count them up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 out of 25. And then in this case, that would be my final answer. That is the probability. It's just 9 out of 25. That's it. A lot of people ask, do you count this little dot here in the middle twice? No. You only circled it one time, so only count it one time. Okay, so that's it for that part. So we're going to move on to part 3. If you need to take a little break, I get it. This video is kind of long. So if you need to take a break, go ahead and take a break. But I'm going to keep on trucking from here. So this next one says, what is a tree diagram? That's what this next section is about. So a tree diagram is used as a visual representation to show all of the possible outcomes. I can't spell today. Outcomes in each of their probabilities. Haha, I spelled that one right. So I'm going to show you guys what these look like. So this is what a tree diagram looks like. So you'll notice here that I have these arrows coming out. At the end of each arrow, I have something written there. So it correlates with this question. So let's read this question. It says bag A contains 2 red, 2 green, and 1 blue marble. Bag B contains 3 red, 1 green, and 3 blue marbles. A coin is flipped to decide which bag a player will choose a marble from. So in this case, So what this is saying, so we have first, like, this is kind of written in a weird order, but like the process of the order of the events is the first thing you're going to do is you're going to flip a coin to pick a bag. That's what it says here. A coin is flipped to decide which bag a player will choose a marble from. So that's the first thing that happens. In this case, when you flip a coin, it's like you either get heads or tails. You know, like when you call heads or tails when you flip a coin. So in this case, what they did was they assigned bag A as heads and bag B as tails or whatever, something like that. So they're saying the outcome of you flipping the coin to pick a bag is you're either going to end up picking bag A or bag B. So those are the outcomes of that first thing happening. After that, you're going to reach into one of these bags and you're going to pull out a marble. The potential marble that you get is either going to be a red marble, a green marble, or a blue marble. From either bag. Both of the bags have red, green, and blue marbles. So that's what this R, G, and B represent. Is like first I pick bag A, then I'm picking a red marble, a green marble, or a blue marble. I pick bag B, I'm picking a red, a green, or a blue. So from here, when you are given something like this, like a tree diagram, what you are going to be filling in is the probabilities. They give you all of the outcomes. You're going to go in and fill in what those probabilities are. So I'm going to show you guys how to do that. So if I'm flipping a coin to pick a bag, we already talked about probabilities of flipping a coin. So if let's just for a second pretend like we assigned bag A to be heads, like when you flip the coin. We already know the probability of getting heads when you flip a coin is a 1 out of 2 chance. There's 2 possible outcomes and one of them is heads. So it's 1 out of 2. The same thing applies for bag B. It's a 1 out of 2 chance. 2 possible outcomes, one of them is tails. So that's the first part. So now from here, now that I've picked bag A, let's for example, let's just pretend for just a second that we just picked bag A. From here, I'm going to reach into the bag and I'm going to grab a marble. So now I got to figure out what the probability of each of these types of marbles are. So the first thing you're going to do is you're going to figure out how many marbles are in bag A. In that case, that's going to represent the total number of outcomes, the total different things that you can get from that bag. So in this case, we have 2 red, 2 green, and 1 blue. If you were to add up all of the marbles, that would be in total 5 different marbles. So in bag A, we have 5 marbles, 5 marbles, and 5 marbles. And you might be like, Miss Barnell, why are you doing that? That's because in this case, my total number of outcomes is 5. So the probability of me pulling anything from that bag is going to be out of 5. In this case, I'm going to figure out how many of those marbles are red for my red marbles. I'm going to figure that out. In this case, it says in the question that there are 2 red. So what this means is I'm going to put a 2 on the top of the fraction here. I'm going to rephrase this for just a second, and I'm going to say the probability of you picking red, there are 2 red marbles out of the 5 in the bag total. So there's a 2 out of 5 chance that you pick a red marble. So 2 out of the 5 of them are red. In this case, you're going to do the same thing with the green. We know that there's 5 marbles total in the bag. 2 of them are green, so it's a 2 out of 5 again. Lastly, for blue, in this case, it's just 1 marble. So you can just put that right there. So from here, I want you guys to try to fill out this next part on your own. Figure out how many marbles total are there in bag B. Put that on the bottom of the fraction for each of these parts. And then from there, fill out the top part of each of the fractions with how many red marbles there are, how many green marbles there are, and how many blue. So try that on your own. I'm just going to go ahead and do it. So in this case, with this one, we have 3, 1, and 3. So there are a total of 7 marbles in each of them. In this case, there were 3 red, so it's 3 out of 7. There's 1 green, so 1 out of 7. And then 3 blue, so it's 3 out of 7. Okay, moving on. So this first question says, find the probability that a blue marble was chosen from bag A. So in this case, what's happening is first bag A was chosen. So in this case, in this situation, first what happened was bag A was chosen from the coin flip. Then after that, we picked a blue marble from it. So we're looking for the probability that we get bag A and we picked blue. So that is a step-by-step process here. There's two things that had to happen, bag A, then blue. So how you're going to figure out the probability of that is you're going to go up to your tree diagram and you're going to follow that specific path. So in this case, starting over here on the far left, the very first thing that happened was I went to bag A. We picked bag A. So in this case, to get bag A, there was a 1 out of 2 probability. So I'm going to write that down there. I'm like, oh, okay. It was a 1 out of 2 to get bag A. That's the first step. From here, after I picked bag A, to pick bag B, blue marble from bag A, there was a 1 out of 5 chance. So to follow that path, I'm crossing through this number, this 1 out of 5. So I'm going to put that next. I'm going to write that after the 1/2, 1 out of 5. In that case, we have 1/2, we have 1 out of 5. So those are the two different things that might happen. Or those are the two things that happened. We picked bag A, we picked a blue marble, we passed through the 1/2 probability, the 1/5 probability. I wrote both of those down. So because those are two different things that happen that are happening at the same time, you are going to multiply those together, just like what we did in part 1. Two different things happening at the same time, bag A and then blue, you're going to multiply those two different probabilities together. So when you multiply fractions together like this, you're just going to multiply straight across. So 1 times 1 is just 1, and then 2 times 5 is just 10. And then that's the answer. There's a 1 out of 10 chance that you pick a blue marble from bag A. So using the same kind of process, I want you guys to try number 2 on your own if you'd like. If not, I'm going to go through it. This one says to find the probability that a green marble was chosen from bag B. So in this case, this is the path I'm following now. I'm going down to bag B, and then I'm going to green. So in this case, to follow that path, I cross through this 1/2, and then I cross through the 1 out of 7. Those are the two numbers that I cross through. So that's what I'm going to end up multiplying here. 1/2, and then 1 out of 7. Again, cross through that, and then cross through that. In this case, 1 times 1 is just 1, 2 times 7 is just 14. And that would be the answer for that. Okay, this last question that we have here, number 3, it says find the probability that a red marble was chosen. So in this case, you'll notice that the previous question specified a bag, this one does not. So in that case, since this question didn't specify a bag, we're just going off of how could I possibly get a red marble? Well, there's two different ways. You could either get a red marble from bag A, or you could get a red marble from bag B. So what I'm going to do is I'm going to find the probability of each of those individually, just to kind of start it off, and I'll show you guys what you do from there. So the process is the same. So let's find the probability of getting a red from bag A. So to follow that path, I start at the very beginning. I go to bag A first. I cross through 1/2. So I'm going to write 1/2 there. After that, to go to red, I cross through this number 2 out of 5. So I'm going to put after 1/2, I'm going to put 2 out of 5. So I cross through 1/2, then I cross through 2 out of 5. You're going to multiply those together. So multiply straight across. 1 times 2 is 2. 2 times 5 is 10. So it's a 2 out of 10 chance. So from here, but there's another way that I could get a red marble. That was the bag B way. So let's find the probability of getting that. In this case, I follow the path. I go through 1/2. I go through 3 out of 7 to go from bag B to red. So in this case, 1/2 times my 3 out of 7. In this case, multiply straight across. 1 times 3 is 3. 2 times 7 is 14. So those are two different ways of getting a red marble, like the question says. That's the probability of the two different ways. So when you have this situation where you have two different ways of getting something, and you found those two different individual probabilities, at the very end, you're going to take them, and you're going to add them together. I put a multiplication symbol, but I meant to put a plus. You're going to add those two probabilities together. So 2 out of 10 plus 3 out of 14. I'm going to show you guys a cheat on how to do this in your calculator rather than showing you how to do this yourself. If you have your calculator, something that you can do to do this instead is type in 2 out of 10 as a fraction into your calculator. So put a parenthesis and then put 2 divided by 10. Your calculator will read that as the fraction 2 out of 10. And then just do plus and then a new fraction, so a new parenthesis, 3 out of 14, or 3 divided by 14. And then hit enter. In this case, it's going to give you a decimal. Since we've been using fractions the whole time, I want to keep my answer as a fraction. So what you're going to do is on your calculator, I know yours has a different button than mine. You're going to hit the second button, and then you should have a button on your calculator that says PRB. So you're going to hit this second button and then hit that button. I don't have that on my calculator, so I'm just going to do some magic here to kind of do what I'm going to do. In this case, it should have like a D to F or F to D, like an arrow in between them. Mine just looks a little bit different. But if you hit the enter button on that, it's going to give you a fraction. If that was confusing, you can just ask your math teacher and they'll show you how to do it, how to put this into the calculator. In this case, that's just how you do it. It's going to be 29 out of 70. All right. So that is going to be how you work with a tree diagram. So I'm going to leave that up here for just a second. Just make sure you got that written down. So from here, that's going to be the end of this lesson. So if you are done with this video, there are 2 things that you are required to do from here, and that is show your teacher your notes and then take the quiz. You do have to pass the quiz to be able to be done with this little section. Those are the 2 things that you have to do, but there's 2 optional steps that you could take there in between the notes and the quiz. Is you can ask some questions, ask the teacher some questions, especially if there was a lot of stuff in here, if anything didn't make sense. And then you can also try some practice problems. There are some practice problems on the Canvas page that you can use to help you practice some of the things that we did here. So go ahead and do those. If you have any questions, let your teacher know. If this is your last credit recovery video, congratulations. You are good to go. You've made up your credit. If not, I'll see you in the next video. Have a good time.